I'm a research and technology manager at Siemens, with taking care of the data and simulations. I'm not an expert on wind energy. We serve all the different products within the Siemens family. As you know, Siemens Gamesa is not part of Siemens. But anyway, so here I'm here to walk you through the digital twin history, the outlook, and how they could help digitalization. So going back to the gas shortage for naming, so in the 70s, we could start, like setting the first proto-digital twins. So think about the advancement of computers at that time. So you can think that computer graphics started to shut out, right? And then as engineers, they started to use geometry models, right? So they were very stiff, non-parametric. If you had to do any change on the geometry, probably you had to start from the beginning. But that was the onset of one aspect. The second aspect was more on the simulation side, where also the computer advancements, they started to infer that some scientists, they started to build some algorithmic to solve PDEs, think about finite differences, finite volumes, and things along those lines. And then at the 70s, the computers, they were powerful enough to hand to some engineers these small solvers, right? Think about heat transfer or aerodynamics, right? Fast forwarding to the 80s, that's what we have, the rise of computer-aided engineering. So a couple of changes, like based again to the great advancement of computer. The first one was computer-aided design models. The first geometry models that we discussed at the beginning, they started to be a little bit more flexible. They were started to be able to cover more decisions, right? And you were able to reuse partially some of the models. When it comes to the physics, the engineers and researchers, they started to co-simulate different simulations, right? So that you were able to analyze more properly your products. And then finally, the increase of memory and the increase of clock speed on the computers, they also allow engineers to focus not only on components, but also on systems, right? Because they have memory enough to cover the systems. And fast forwarding to the 2000s, hopefully everybody here was already alive at that time. So we have the product lifecycle management pervation, right? So think about product lifecycle management, where you start, to be able to connect different models from design into commissioning and into manufacturing, so that the companies, they started not to be silos, but to be more connected. And then this one obviously started to increase the product performance, right? And also the traceability and other aspects that they were quite useful in the future. Now, what I came here to present, the digital twins. So here they have 3 additional ingredients from the ones that I mentioned before. The first one is real time. And for real time, here you have 2 aspects. The first one is the simulations, all these finite volumes and finite elements methods that they were developed in the past. Because of the continued increase of power of the computers, they were becoming more fast. But more importantly, AI has been able to support and to push some of these models into reduced order models, so you could have real-time assessment of your products. The second part of real-time is being in sync, right? So all the 5G and in the future 6G connectivity, they allow the sensors the sensor data to be immediately available to the simulation models. And then in that way, you could actually sync your models to your actual asset, right? So this is very, very important to have a digital twin that really represent the actual physical asset, right? Then the second ingredient is any business as a service. So you can imagine that with the cloud technology, now we are able to offer a lot of things in terms of subscription to our customers. And finally, the product lifecycle management, we commented before, that started to connect design, commissioning, and manufacturing. But now with the digital twin era, you are able to extend throughout all the life cycle, including operation, right? And once you are able to have a digital twin in the operation, you are able to do a lot of, games virtually before you do any change on your physical asset. So you can imagine that you could predict what's going to be the behavior of your physical asset, but also you can prescribe the behavior so that you get the most out of it. And with the digital twins, what we are able to get. So we are able to increase performance in all the different industries that we serve. And also we are able to reduce costs, right? Mainly because we are able to play games virtually before do anything physically, right? Whenever you do things in the physical world, you can break equipment, you can have safety issues with your workforce. So, and obviously it's very costly, right? Because you need to not only pay for the hardware in advance that might break, but also, you need to devote a lot of time to set experiments. So here are a couple of examples that we did specifically for the wind industry. Here, the first one is about wave blockage and also the terrain influence. So we have a customer that had a wind farm, and then they were not able to produce as much energy as they thought. So they thought that the issues, they were the wave blockage and the terrain, the orography, as I mentioned. So they decided to work with us to do a digital twin of the farm. Then we make sure that this time we model the wakes and also we model the orography of the farm location. So we were able, you can imagine this one was a very expensive model. This one was not real time because a lot of cells there. But then they were able to match, like with this model, the actual output that they were getting. And then they started to think what to do for the next farm, right? And then they start playing with design optimization, basically trying to change the different locations of the turbines so that in the future they can make the most out of it. Second example for the wind energy is about a supplier of floaters. So they were quite active. They are quite active on the oil and gas industries, on the deep sea platform. They wanted to get into the offshore part of it. And then we had a similar study where they wanted to have a virtual model so that, whenever they design the updates, like from the oil and gas to the wind turbines, they are going to be able to do it fast and in a short time. So again, they build us here a virtual model, and then they match the response with the actual test bed that they had. And once they have it, they started to play games, how to change the geometry, how to change the materials, so that they are able to provide the new market that they wanted to show. And here, the last example, which is about like serving operations for wind turbines. This is our executable data twins. You guys might have seen that already, but the idea is that you have this simulation model that is based, is hybrid in the sense that it has machine learning on it. It's a reduced order model, and then it was connected with the sensors for this instrumented blade. And then for whenever, you were exciting whenever you were exciting the blade, the sensor information was used to tune the actual simulation model. And then automatically, not only you have readings on the limited locations where you have the sensors, but you have reading in the whole domain of the blade. So you can imagine that this one is going to be quite useful. First of all, you don't need to have a lot of sensors, right, to be able to observe what's happening in the full blade. Second of all, each blade is going to be different because each blade is informed with their own sensors, meaning that you are able to track the degradation of each of the blades because they are tuned based on the sensors. And more importantly is that they self-update because since the stream of the sensor values, they change every time, you are able to get up to date with the blade degradation. Now that I've shown you the digital twins and a couple of applications, how does it help on digitalization? So here we have a framework that we call Sustainable Digital Enterprise. And you can see that in the core of it, you have the digital twins of the product and also the digital twin of the production, right? So these digital twins, they complement the physical asset. So you are able to augment the data that you have from the physical world. So more data and more quality, we get into more detail for that. Also, we have what we call data threads, which are the next generation of PLM, product lifecycle management, where you are able to build a framework that seamlessly connect your product with your production, and also throughout all the life cycles of the two of them and whenever they relate to each other, right? So in that way, you are able to leverage all the physical data, connect it to the digital data, and try to make the most out of it. And also, I'd like to capture also your attention on this external part, what we call the digital world and the real world, which are basically the context where your product and your production operates. So you can imagine that you might have a product, but it might be in different locations, in different geographies. You might have constraints from the supply chain management and things along those lines. That's what we are trying to model with this digital world. Let's get a little bit into those. So for marketing purposes, we also call it industrial metaverse. But here, what you see is that you not only see the digital twin, you also see the context around it. So the first thing that I would like to capture your attention is that everybody can visualize, like your product here. It could be photorealistic. So if you have any computer vision technologies that needs to be trained upfront, you could use this digital world to train your computer vision techniques. You don't need to wait for the product to be built to do that. Then other important thing that you can see here is that you could interact with your digital twin. So if you are any decision makers throughout the product life cycle of the digital twin, you are able to change your decision, and everybody else is going to see what's happening, right? And people see the real world, right? It's not that you need to have, like a training on a special tool so that you are able to interpret what's happening, right? Here you see the rendering of the real world, and the barrier for people to get into that to collaborate is very, very low. You don't need to use any specific tool. And finally, the most important thing is that these digital worlds are connected to your physical world, right? So whenever you make any decision on what to change, like you do it with your virtual world, but then eventually you would download it to the physical world. This is another example, not only for the product, but also for the factories. In this case, same thing. Before, if you have a factory and you want to change from manufacturing of one platform to another platform, you could experiment the change virtually without disrupting your actual production. Then playing games, change the layout, change the tunings of your machines, and whenever you optimize it virtually, without having to stop anything on your physical factory, then you deploy, and immediately you are able to, with very limited testing, you are able to optimize, your plant for the new platform that you want to do, or for the new schedule that you want to have, because you might have any also issues with the schedules. Then thinking about the future. So I guess a keynote nowadays cannot be done without talking about Gen AI. So how Gen AI is going to disrupt the digital twins, and what are the opportunities for the digital twins? So the main question here that we want to answer is that how the success on the AI, on the consumer AI, could be translated as a success for the industry AI. There are a couple of differences, right? Because, like in the consumer AI, hallucinations, they don't have a lot of implications, right? So if you get a recommendation from Amazon and then you get a book and you don't like the book, after 3 pages, you just stop reading the book. Or in Netflix, if you get a TV show recommendation that you don't like, the worst thing is that you just lose 30 minutes, right, of watching the first episode. But for industries, it's totally different, right? So we are talking about, most importantly, the safety of your people. So this one could have implications, right? If you have a hallucination on the industrial application, this one could be very, very, very hard. Obviously, you could destroy your equipment, a lot of money, and also your reputation, right? So taking care of the hallucination is very, very important. So our answer for that is that we need data, but more importantly, the quality of the data is very, very important, right? Because the quality of the data and the amount of good quality data is going to allow us to ground all the AI, like to actual, physical grounded, like decisions that they are going to reduce the number of hallucinations. Here on the right side, you see a pyramid that on the bottom, right? So you see the different levels of data needed, and whenever you go up, you see like how the domain knowledge could help you to reduce the amount of data, right? Obviously, we still need a lot of data, and that's where I think that the competition topic of this task is very, very important. So even though there might be some IP restrictions, there are some interesting federated learning methods that they allow you to keep your IP while also, like you are able to train AIs, right? Like from different companies without, like leaking the IP from one to another. But then whenever you go up in terms of the domain knowledge, like you start having a structured data, which is another topic, I believe, of the task, right? So the first level is standardized data that could be read by anybody knows how to read it. Then labeled data, where you are able to get more metadata, right, of the actual data. And finally, the context, right? So going back to the digital twins, if you have your asset operating in a certain geolocation, right? So you know exactly the context of it, like the wind at that time, so you are able to know the world around your product, right? When you were measuring the data. And finally, the ice on top is the digital twin from our point of view, where not only you are able to structure the existing data, but you are able to generate data and generate data in corner cases, right? Where you might not have data, and it might be very important to, like to make sure that you don't have hallucinations, right? So the top of the pyramid is very, very important. It's not only about the structuring, it's about augmenting data in the scenarios where you think is the most critical. Here we have a contextual view of this structuring of the data. On the bottom, you see the different sources of data from your product and for your production line. On top, you see the different applications that you might use for you or for your customers. And then in the middle, you have the semantic data model, right? This highway of or this data thread, which is going to allow you to connect to the right data at the right time. And here is very, very important that these applications only has the right amount of data, right? Because like with all the connectivity that we have now, too much data might mean overflow of information, and you might not be able to make the most out of it, and the AI might have hallucinations, right? So it's very important that not only you provide the data in the right time, but also you only provide the right data. And that's why this semantic data model is designed to be able to serve, like the specific request of these applications. Here you might see that on the rightmost side, we have the simulations, but here, that's where the digital twins, they could increase the amount of data, and they are able to augment your data repository, so you are able to serve more use cases. Talking about applications, I guess another important thing on every keynote is talking about copilots. So here is how we think about copilots. For us, talking about the value of the data. So this one inspired us to think about copilots in terms of foundation models and also domain experience and domain expertise. On the rightmost of the screen, you see how we see, like the combination. On top, you have the foundation models. And then in the middle, you add domain knowledge that could be in terms of semantic data models, but also in terms of digital twins that they augment the data. And then based on that, we build what we call the industrial copilots. You might see that we are talking about industrial foundation models. I guess this one would be a topic for another keynote, but we are assessing whether it makes sense, like that in engineering, the modalities of engineering, they are different from text or from image, right? Which are the main modalities of the existing, like in the, foundation models. So here, the idea is that if we want to bring simulation, we want to bring geometry, if we want to bring, visualizations, all of that, they might not be nicely covered by the current language models or image models, right? So we are assessing whether it makes sense to have our own industrial foundation models. And then on the left side, you see the different copilots that we have right now. All of them, they are going to be based on these industrial foundation models that understand the modality of engineering. And then on top, we are going to have these copilots, some for serving designers, other for serving automation engineers, other for serving operators and service people. And maybe a small note on the future here for copilots. So in the last 10 years, we had chatbots, right? Where they were able to answer specific questions based on documentation. Now we have copilots that they are able to do low-level tasks for you. For example, on the design copilot, you could, I'm going to show you a video. You're going to be able to ask them, please, could you change the geometry of this surface? And they are going to be able to do. So they are going to have a small level of autonomy, and they are going to do low-level tasks. Then in the future, we see agentic AI, where the level of autonomy of these agents, they are going to increase. And then the analysts and the simulation people, instead of asking for low-level requests, such as increase the thickness, they are going to ask for higher-level requests, such as, please, could you generate a model based on this requirement, right? That's what we see in the future, right? Maybe 5-10 years time. Let me show you some of the copilots that we are putting together. This is the design copilot. This one has the capability of a chatbot when it's going to help, like new users to answer questions based on documentation, but also it has some of the characteristic of a copilot where they are able to do small things for you, like changing geometry or doing a small reports. Let me play it for you. All right, you see this one in NX, so it was kind of like targeting designers, right? Changing geometries and things along those lines, and you were able to see that they were able to do low-level tasks for you. You are still in charge, right? The designer is still in charge. And this is another example, maybe more for the automation people. So for our PLCs, they need a special programming logic controllers. They need a special programming language that not everybody knows how to use it. We have this tool to build this logic. And then here, we could show you again an example on how to automate things for the actual automation engineer and how to generate code on this SCL language, which is not a very welcome language. So here, when I play at the beginning, the user is asking to open this project. I don't know if you see, but this is the name of the project. The project opens here. And then it opens also, like all the different windows that they are customized for the user. And now the user is giving instruction about the different blocks, right? To explain what this logic is doing. Imagine that you are taking the project from somebody else and you don't know what he's done. So here you will see that everything is explained. And now they are asking for a modification, right? So here, once you understand how the code work, you ask for the modification. You might not be an expert on this, like PLC code, but then they tell you, like the different changes that they need to be done, and we reflect the changes in the actual project. So how I'm doing with time? Yeah, 10 minutes. Perfect. So here I'm just wrapping up with Sir David Attenborough, fascinating stories. Also fascinating accent, right? He's got, like yours, yeah. Then this typically he finishes his documentaries with nice quotes, right? And then in this quote he's talking about that we are aware of what we are doing to the planet, right? But also the positive note that also we have the power to do something about it. And I think that one of the powers is digitalization and digital twins, right? So I think that the digital world can really affect the physical world, right? And then before I close it, I want to show you one example that we did to help biodiversity. So we built digital twins of coral reefs that they support environmentalists to make the right decisions and also scientists to understand what's the dynamics of these amazing, living organisms. Let me play for you. All right, and with that, I close the keynote. I hope you like it.
We have a question from the audience, from the online. Anna Maria, you asked a question quite a long time ago. Do you want to ask it? Because I'm not quite sure what it was referring to, because it was kind of the beginning of the presentation. Can you speak, Anna Maria, or can you? So Anna Maria asked how much do the simulations cost in terms of time and money, but I don't know exactly which simulations you were referring to at that point. Do you want to?
The digital twins simulation.
You answer that question? Maybe we could get to Lindsay.
So, yeah, perfect. Yeah, thanks for the question. Which simulation? The CFD for the farm?
I was looking at this ship with the container and how it works, because they say that you cannot know how the design works when looking at the digital twin. But how much does it cost this in terms of power, for example?
For the ship, right? For the ship that I showed.
But that's one example.
It was done for HD Hyundai, right? So this one.